So now that we're dealing with rational functions instead of just rational expressions, it might seem a little daunting. It might seem a little bit more complicated, but in essence, it's just the wording that's different, and the fact that we're looking at a function, so it's represented by an equation, which can be represented by a graph. But literally, all we're doing is taking what we've already been doing and putting an equals f of x or equals g of x before it. The process is exactly the same. So when we're asked to find r of x, which equals f of x times g of x, and then we're given these two rational expressions, or rational functions, f of x and g of x, with these rational expressions, the process is just the same. We take whatever the values are. So r of x equals f of x times g of x. So we just take 3x minus 21 over x squared minus 9x plus 14, and then we multiply times g of x. 2x squared minus 8 over 3x plus 6. We're looking at the same exact process we had before. Factor all the numerators and denominators. So 3x minus 21, we factor out the 3. X squared minus 9x plus 14. What two numbers multiply to 14 and add to negative 9? Well, we know they're both going to be minus because we have a plus 14 and a minus 9x. And in this case, it's just minus 7 and minus 2. And then that's times. We factor out the 2. We end up with 2 times x squared minus 4. On the bottom, we factor out the 3. So that's 3 times x plus 2. Now, if you'll notice here, first off, we can already cancel the x minus 7 and x minus 7. Those are common factors in the numerator and denominator of our first rational expression of f of x once we've factored it. And also, we can factor x squared minus 4. That's going to end up equaling, we'll go ahead and simplify this. That's going to be 3 over x minus 2. And then times 2 times x squared minus 4 is x minus 2 times x plus 2. And again, that's over 3 times x plus 2. Well, now we can cancel common factors here, x plus 2 and x plus 2. And then if we multiply across the top, multiply the numerators, multiply the denominators, we end up with 3 times 2 times x minus 2 over x minus 2. Excuse me, 3 times x minus 2. I forgot about this 3 over here. So 3 times x minus 2. Well, now we can cancel 3, x minus 2, x minus 2, and we're left with just 2. So if we multiply f of x times g of x, we end up with just 2. We also should note, as always, x cannot equal. Now let's look at it when we had all of the factors. X cannot equal negative 2, 2, or 7. Okay, so x cannot equal negative 2, x cannot equal 2, and x cannot equal 7. And the reason for that is because if we plug those in to, for instance, if we plug negative 2 into g of x, we end up with 0 in its denominator. And if we add 2 or 7 to x squared minus 9x plus 14, we also end up with 0 in the denominator. So technically, even though the solution is 2, x can't equal negative 2, 2, or 7. In this case, since we don't have x in the product when we're done, it doesn't make that big of a difference, but it's always good habit to define what x can't equal, to help define the domain of the resulting compound function.